the name indicates pre-formulation here. Okay, pre means before. Okay, formulation. So before formulation or before preparing any dosage form, if you are doing any studies, they are known as pre-formulation studies. So pre-formulation studies is a very important study, means it is an important step you have to do before the formulation. So if you are doing a pre-formulation studies or a pre-formulation evaluation test, it will help to design a formulation in a better way, or in order to form a stable dosage form, we need to do the pre-formulation studies. Now coming to the contents of our topic, mainly in pre-formulation, we will study about the introduction of a pre-formulation. Next, what are the main goals and objectives of pre-formulation, and study of a physico-chemical characteristics of the substances, BCS classification of a drugs, and the last one is the application of a pre-formulation in a formulations. Now coming to the definition of the pre-formulation. So what is a definition of the pre-formulation? Pre-formulation commences, means this step will start when a newly synthesized drug, it will show a sufficient pharmacological action in either animal model or in a human model to warrant the evaluation in a man. For example, you want to prepare one tablet, okay. So before preparing a tablet or before releasing the tablet into the market, you have to do some trials on an animal as well as on a man. So in most of the studies, what they do is, if a human volunteers are not available to some extent, they will do in a group of human volunteers, but they will compare the animal, like physiology of animal, which is similar to that of a human, and they will give a tablet to that particular animal and they study how the tablet will be dissolved and what is the performance of the tablet in a animal model, and they predict the same, okay, it is behaving as such in animal, so the same thing will be happened in a human volunteers or in a man also. So that is a pre-formulation, means the pre-formulation will start from the first step. Okay, whenever you are going to prepare a newly drug, okay, so newly drug will be given to an animal model to exhibit some pharmacological action, and that pharmacological action is correlated in case of a human beings. Next, so it is a first step in the development of a dosage form. Next, coming to the goals and objectives. So if you see, the main objective of the pre-formulation study is to generate the information which will be further useful in the formulation and in developing the stable and the bioavailable dosage form. Means why you are doing this pre-formulation study, or what is the main agenda or the purpose of this one? Ultimately, it will help in producing a one stable dosage form and the one which will be bioavailable. Bioavailable means which will be absorbed. Next, coming to the next one is to establish the necessary physico-chemical properties, like you can do the preliminary particle size, particle shape, next whether it is undergoing any oxidation, that is a chemical. So, to establish a necessary physico-chemical properties of a new drug substance, ultimately why you need to study these physico-chemical properties? If you do not know or if you are not aware of these physico-chemical properties, ultimately what will happen? It will affect the drug performance and development of an efficacious, stable and a safe dosage form. Without doing a proper study, if you have prepared a tablet, without doing anything, if you have done a preparation, then ultimately what will happen? There will be loss of that efficacy of that particular tablet. Okay. So, what is the main motto? You have to study for each and every dosage form physico-chemical parameters or the properties. Next, to determine the kinetic rate profile, like whether it will undergo zero order release or a first order release. So, based on that, they can also design the dosage forms. Next, to establish the compatibility with common excipients. For example, the familiar we have. For example, there are amine drugs like CNS drugs. Whenever you mix amine drugs with a lactose moiety, Okay, this will be used as a diluent in the preparation of a tablet. So ultimately what will happen, the tablets will be converted into the brown color, which is known as a famous Maillard reaction. Okay, so what you have done, without proper study in the preparation of these tablets, amine drug tablets, you have added lactose as a diluent. So ultimately the tablet has been discolored and there was some decrease or decline of the absorption. So you should have a proper thorough of your excipient and you have to choose. So if in this case what is happening, both are incompatible with each other. So you have to study the compatibility also. For this drug, this excipient will be selected. This is compatible with this drug. You have to study it. Next, to provide insights into how drug products should be processed and stored to ensure the quality. Means, for example, you have a raw material into which dosage form you have to prepare either tablet, capsule, injections or a dry syrups, and after preparing you have to maintain that storage conditions. If you are not maintaining the storage conditions, then it may undergo degradation or decomposition. So ultimately you have to follow each and every step in order to produce a stable dosage form and a good quality product. Next, to develop an optimal drug delivery system, means it should not have any side effects, it should be targeted to the site, okay, frequency of dosing should be reduced. So you have to see in such a way that the patient should be comfort and action will be exhibited more, okay, that should be done. Coming to the physicochemical characterization. So the main part in the free formulation studies is a characterization of physical properties as well as chemical properties of your dosage form or a drug substance. So coming to the two parts, physical properties, chemical properties. So coming to the physical properties, we have an organoleptic characterization such as a odor, taste, appearance of the product, you have to check it. Next, bulk characterization such as a particle size, shape or crystallinity product or whether it is amorphous product, you have to check it. Next, solubility profile, okay, whether it is having a good solubility or whether it is depending upon the pH to release from that particular site. So you have to study about all these parameters. Next, coming to the chemical properties of the drug substance, hydrolysis, these are common. Whenever you use the term chemical, these are the common reactions which we can see in a general view. Okay, so hydrolysis, oxidation, reduction, racemization and polymerization. So we'll study in detail about all this. So coming to the first one is a physical properties. In physicochemical, first we are going to study about the physical properties. So coming to the physical properties will affect the structure and the stability of the formulations. Means if you are not doing or if you are not evaluating the physical properties of your drug substance, without that if you have prepared a dosage form, so what will happen? It will affect the bioavailability of the drugs. Bioavailability is nothing but the rate and extent of drug absorption is known as bioavailability. So therefore, the physical properties of the drug are very important in designing a dosage form or a formulation. So under physical properties, we have some 3 to 4 sub-properties. So the first one is a organoleptic characterization. As I've told you in the previous introduction only, organoleptic means you have to evaluate the color of your product, odor, that is a smell, texture and the taste. Okay, so this should be checked for each and every drug substance. Apart from that, you also have to check whether it is good in appearance or whether it has converted to other color. The standard, as per the standard reference, it should be white color, but it has been converted into a milky color or some grayish color. So you have to check that also. Next, color should be eye appealing. So whatever colors you are adding, it should be very pleasing. Okay, like light pink. If you see, many dosage forms are available in a market. Light pink, light orange. It should not be as such a bright like a red color, dark green color. So it should be very pleasing whatever colors you are adding. Next, odor and taste should also be pleasant. Next, impurity should not be there and always the drug should be in the purest form. So, in order to check this, we can do the assay for your drug, whether it is having a purity or not. Coming to the next is a bulk characterization. First, we have completed organoleptic characters in physical properties. Next is a bulk character. So, in bulk characterization, which properties you are going to study or which parameters you are going to study? Crystallinity, amorphous, polymorphism. Next, fine particle characterization, that is a particle size and surface area. Next, density of drug products or drug substance, almost 3 to 4 types of density we are going to study. Next, pod of flow properties such as angle of repose, Hausner ratio, Carr's index, density. You are going to study about all this in a pod of flow. So, all this evaluation will come under bulk characterization. Now, coming to the first one is a crystallinity. So, what is the meaning of a crystalline substance? We come across these terms like it is a crystalline product or it is an amorphous product. So, what is the meaning of a crystalline? Whenever there is a proper arrangement of the molecules and it should be in a repetitive manner. If as such the atoms are arranged, then such product is known as a crystal product. And coming to these products, whatever the crystal products are there, they are of a different shapes, cubic, tetragonal, orthorhombic, you have some prismatic, many shapes are available, means you cannot see from the superficial. When you observe under the microscope, then they will be of different shapes. Next, in crystal substances, we use two terms. One is a crystal habit and another one is a crystal internal structure. So, by seeing this term, you came to know that if you are studying about the internal property, then it is known as crystal internal. Okay, what is the meaning of crystal habit? Outer surface. If you are studying about the outer surface properties, then it is known as crystal habit. Crystal habit means outward, internal, these two will be studied. Okay, so ultimately it will affect the bulk and flow properties as well as the stability of the product. Next, degree of the crystalline product, it affects the hardness of your dosage form, density, transparency as well as the diffusion process. Next, the crystallinity has a greater effect on the absorption of a drug. So, in crystalline compounds, again based on the arrangement of the molecules, again there are of two types. One is a stoichiometric compounds and another one is a non-stoichiometric compounds. Okay. So, when you compare out of these two, stoichiometric compounds are preferred in case of formulations. Non-stoichiometric adduct, they are not using nowadays. It is undesirable. Next property is a amorphous product. So, what is the meaning of amorphous? They will not have any proper arrangement, okay. Without any arrangement or the skeleton backbone, if the molecules are present as such, then such compounds are known as an amorphous compound, okay. Next, amorphous compound will have a rapid, prepared by the rapid precipitation as well as the lyophilization process. So, what is the other synonym of the lyophilization process? Freeze drying. Okay. So, they are prepared by the precipitation process and the lyophilization process. Next, coming to the amorphous products, in this, some compounds will have different energy states. So, here they are comparing with that of a crystalline compound. Okay, here they are comparing with a crystalline compound. So, always amorphous will have a higher energy state or a higher thermodynamic energy when compared to the crystalline. And coming to the solubility as well as absorption, amorphous product will have more solubility than the crystalline. For example, I will give a normal example in your household. You have two types of salts, okay. One is a fine salt, one is a coarse salt. So, you take a glass of water, add fine salt into the water as well as coarse salt into another glass of water. So, which will dissolve fastly, very fastly? Fine salt. So, fine salt is nothing but amorphous form, coarse sort, crystal type is known as the crystalline compound. So, always the amorphous form will have more solubility. If it is having more solubility, the absorption will also be more. Next, after storage, okay, or during the storage time, what will happen? This amorphous compounds, again they will revert back, okay, to the crystalline forms or to the stable forms. So, as they are not having a stability, means they are converting from a one form to the another form, this is a major drawback for the formulations. Next one is a polymorphism. So, polymorphism is nothing but the ability of a compound to present in a many forms is known as a polymorph, and the phenomena is known as a polymorphism. For example, I will give, today you disguised yourself as some policeman. Tomorrow you will ready as a doctor. Day after tomorrow you will get ready as some other person. Means you are same person, but you are appearing in a different forms. Okay, that is the meaning of polymorphism. So, poly means many forms. Okay, so if any compound is existing in a more than 2 or 3 forms, then such compound is known as polymorph, and the process is known as a polymorphism. Next, coming to the again polymorphs. Again in polymorphs we have a 2 types. One is an enantiotropic and another one is a monotropic. So, coming to the enantiotropic polymorphs, for example, you have prepared a substance, a drug substance you have prepared. Okay, so this will be converted into a B, means for example, this is a X compound. X will be present in A form and B form. You have prepared A form, but it has been converted to the B form. So, how it has converted? By altering the temperature or the pressure. If one form has been converted into the another form, then it is known as enantiotropic. Next, coming to the second one is monotropic. Monotropic means monarch, like single. I will be as such, I will not go anywhere. Okay, that is the meaning of monotropic. So, monotropic, even if you are increasing the temperature or reducing the temperature, whatever you are doing, it will not convert into the another form. Okay, so that is the meaning of a monotropic. Next, coming to the polymorphs, as we have seen, we have 2 types of polymorphs. Even they are of different types. Coming to the physical properties, the physical properties will also differ, such as solubility will be different. For example, as I have told you, X will be present in A form and B form. Okay, but the compound is single, but it is present in a 2 forms. Coming to the A will have a different solubility, B will have a different solubility. For example, as I told you, today the person has disguised himself as a policeman. What is the duty of the policeman? To protect the society, whatever he will do. Tomorrow he will be converted into he has converted himself or disguised himself as some doctor. So, doctor will have some other, okay, another day some robber or something. So, what is happening? The same person, but the action is different. So, here also they are same person, but the physical properties will be different. But how you can identify this is the same person, but they are available in a different forms? We have some methods to identify, such as DSC, differential scanning calorimetry, XRD, that is a X-ray diffraction method. So, these are the 2 methods which will identify the density, melting point, difference in their properties of the single compound. Next, coming to this one, they will be available in a 2 forms. One is in a stable form and another one is in a metastable form. So, coming to the stable form, okay, they will have a low energy state, high melting point and the least aqueous stability. Okay, so therefore, they will not change from one form to another form. Now, coming to the metastable, they will have an opposite to that, means they will have a high energy, next low melting point, next high aqueous stability. So, opposite to the stable, these are the properties of a metastable form. So, as they are in a high state, every time they are active. So, what they will do, they will not sit at a one place. They will convert to the other place. They will go to the this place or that place. So, this will happen with a metastable. But coming to the stable, they have always less energy. They will be patient and calm. They will not go anywhere. So, in our formulations, mostly we take a stable form of formulations. Now, coming to the fine particle characterization. So, under this, the first one is a particle size. So, particle size, if you see, particle size means small size, medium size, large size. Okay. So, coming to the particle size, if you are not doing properly, means or what it will do, ultimately it will affect, the particle size will affect the drug release from the dosage form, drug absorption as well as therapeutic action. Means, what is the meaning of this is, if particle size of any drug is less, surface area will be more. If surface area is more, solubility will be more, absorption will be more. Okay. Vice versa for the other. If the particle size is larger, then surface area will be less, solubility will be less, absorption will be less. So, you can see the variance in case of low particle and high particle. So, ultimately it will affect the drug release, okay, absorption, action, stability of the dosage form as well as flow properties. And coming to the particle size, we have some different methods to identify the particle size of the drug substances. So, first method is the optical microscopy method, means you will use the microscope and you will measure the particle size. So, it will give the number distribution. We have a weight distribution number. Coming to this one, it will give the number distribution. Second method is a sedimentation method. In case of sedimentation method, we use one apparatus which is known as an Andreessen pipette apparatus. This was asked in a previous question. They will give these methods which, like Andreessen pipette, will be used in the determination of particle size by using which method? So, the right answer is the sedimentation method. Next one is the conductivity method. So, in conductivity method, they use the principle of a change of a light intensity, and the methods used are Coulter method and the light scattering method. So, you have to remember the main names and what is the apparatus they are using in the determination. This will be asked compulsory in the competitive exams. Next one is the particle shape. So, coming to the particle shape means whether it is a spherical particle, okay, whether it is a oval particle, whether it is smooth, irregular. So, that is a shape of the particle. So, coming to the particle shape. So, particle shape will also influence the surface area of your product, flow properties, packing and compaction of the particles. Next, always the spherical particles will have a minimum surface area, means less, okay. Next, particle surface area, third one, characterization. So, coming to the particle surface area, here the size and the surface area are inversely related to each other. Already I have told you, if the particle size of the product is high, what will happen to the surface area? It will be less. If particle size is less, then surface area will be more. So, you can see both are inversely proportional to each other. Okay. So, smaller the drug particle, greater the surface area, and maximum will be the solubility as well as the absorption. And coming to the methods which are used for the determination of a particle surface area are adsorption method and air permeability method. This is also important. Methods to determine surface area. Next, density of drug substance. So, here we are going to study 4 types of densities. So, basically what is a density definition? It is defined as weight per unit volume, W by V. The ratio of that is known as density, D. So, coming to the density, the first density is known as true density. So, what is the equation for the true density? Powder weight by the true volume. Okay. So, what is the meaning of a true volume? This is will be the assume powders are arranged as such. Okay. So, what is the true volume? The volume excluding the void spaces. So, what is the meaning of void spaces? the spaces which are present in between the particles are known as void spaces. So, removing that space as well as intraparticle pores, small pores, whatever the space is there, if you are calculating that, then it represents the true density. Next, what are the methods which are used for the determination of true density? Gas displacement method or a liquid displacement method. Here also they may ask, in gas we may use a helium, okay. Next, granule density. So, you can see true density means it is used for the determination of the powders. Granule density means mainly it is used in the determination for the granules in the preparation of a tablets. So, what is a granule density? Granule weight by granule volume. And what is a method to determine this granule density? Mercury displacement method. Next, bulk density. Bulk density means you took some powder, you have weighed it 5 grams, okay. Next, you have poured into the measuring cylinder. You have seen that height. Height represents the volume. So, ratio of bulk density by bulk volume is known as bulk density. Next, coming to the tapered density. Now, after pouring into the measuring cylinder, many of these they will do in your B pharmacy practical. Okay, you weigh some amount of the powder, you pour into the measuring cylinder. Okay, you will note this height. Assume it was some 30. Now, you will tap for 50 times, means beating on the surface of this measuring cylinder slowly. After certain time, after 50 tappings, not certain, and after 50 times you are beating the measuring cylinder, you will check this height or the volume. Assume it was some 28. So, what has happened? They have been occupied very closely when you have tapped it. So, that is the meaning of tapered density. Next, coming to the flow properties of materials. Under flow properties, we are going to study about the angle of repose, again density, Hausner's ratio and the Carr's index. So, already we have studied in the previous, that is the density. So, I have started with a Hausner's ratio and a compressibility index or the Carr's index. So, these are the synonyms for this, either Carr's index or the compressibility index. So, coming to the first one is a Hausner ratio. So, what is a Hausner ratio? The ratio of a tapered density to bulk density is known as the Hausner ratio. So, you will get one value. That value you have to check with the standard. Based on that, you can determine whether your sample is having a good flow or a poor flow. In next table, there is a table values, we can see it. Now, coming to the Carr's or compressibility index, this is also ratio in terms of percentage. Okay, bulk density, tapered density minus bulk density by tapered density into 100. Now, this is the standard table, both Carr's index value, Hausner ratio. So, if it is Carr's index is a 5 to 10%, Hausner ratio is 1 to 1.1, then what it indicates? It indicates an excellent flow property. Next, if you see Carr's index 21 to 25 and this one is 1.26 to 1.34, passable, means okay, just like that. Next, last one, greater than 38 or greater than 1.60, extremely poor, means if you have taken this powder, okay, and if you want to prepare into a tablet or capsule, you will not get a proper solid tablet, okay. So, what you have to do, you have to add some lubricant, you cannot discard that material. Then the other step will be you can add a lubricants or glidants, that is the next part. Next is an angle of repose. So, what is angle of repose? Angle of repose is nothing but the maximum angle which is made between the pile of the powder and to that surface is known as an angle of repose. So, what is the formula for the angle of repose? Tan theta, means you are making with respect to some angle. So, tan theta is equal to height of the powder by radius of the powder pile. Okay. So, this is the angle of repose. So, angle of repose, mainly the common method you will be using a funnel method. So, in funnel method what you will do, this is a stand, okay. To the stand you will attach a clamp a funnel, okay. Below this you will keep a piece of paper, you will pour some quantity of powder from this. When you pour, it will form as such. So, you have to calculate with the scale height and radius. You have to insert in that formula and you will calculate angle of repose. So, these are the standard values. Less than 25 if you will get, it indicates excellent. 25 to 30 good, 30 to 40 passable and greater than 40 very poor. You have to remember these tables at any cost. Okay, that is a Car's index table, harshness table and angle of repose. 3 tables you have to remember, one or the other bit will come compulsory. Next, coming to the other properties which will affect this flow property are moisture content. Okay, if there is a presence of moisture, then what will happen? The powder will stick to each other. So, it will reduce the flow property. Next, nature of the particles. Coarse and fine particles show a good flow property. Coming to the particle size, if the particle size is less, then also it will have a good flow property. Next is the solubility analysis of a drug substances. So, here mainly we are going to determine the solubility analysis by pKa, pH and partition coefficient. Means, for example, you took one dosage form, it will enter into your body. So, how it is, we have a fluids like GI fluids, intestinal fluids. So, how it is dissolving in that, and you also have an organs and tissue, how it is passing through that organs and tissue. Next, we have a different pH at a different sites, like stomach pH will be 1 to 2, intestine pH will be some 6 to 8 based on the again large intestine, small intestine, we have a variation in the pH. So, some drugs will release at the stomach area or some drugs will release at the intestine area. Based on the pH also we can modify. So, in order to, apart from that, the pK will also affect the drug release. So, ultimately we have to study about the pK determination, pH solubility profile as well as partition coefficient. Now, coming to the first one is a pK determination. So, under pK determination, as I have told you, if your drug is having a good solubility, it will dissolve in a GI fluids. If it is having a good permeability, permeability is nothing but passing of drug through the membranes. So, both this should be desirable. Okay, and if any drug is having a less pKa, then it will have a more acidic profile, and pH and pKa, if you see, mostly they are a reverse form. So, here they have given a one example of a substance. Assume you took a one acid HA or HCl, okay, you have added into a water. So, what will happen? Immediately it will split into the H plus ions and Cl minus ions. Now, when you put a law of mass equation for this acid, so when you add acid into water, it will dissociate into the ions. So, what is the equation? Law of mass equation, that is Ka equal to product by reactant concentration, A minus H plus by HA concentration. So, what is a K? K is the acid dissociation constant, because you took a acid. In case of similar HCl, H plus Cl minus, when you add HCl into the water. So, how you will write the equation? H plus concentration, Cl minus concentration whole by again HCl concentration. Okay. Next, coming to the pK, as I have told you, it gives the strength of the acid or the base juice, means whether it is a more acidic or a less acidic, it will give the nature of the acidic. Apart from that, percentage of a drug ionized can also be formed. You have took some 10 molecules. Out of 10 molecules, how many has been dissociated into the ion? So, you can find out that also. Ultimately, this ionization can be determined by the Henderson-Hasselbalch equation. So, what is the equation for the acidic drugs? pH equal to pKa plus log of ionized form by unionized form. For basic drugs, pKa plus log of unionized form by ionized form. If you see, both are reverse. Here, the numerator will be ionized and denominator will be unionized. In case of here, the numerator will be unionized and the denominator will be the ionized form. Next, so when the concentration of both the numerator and denominator are same, then what will happen? pH will become equal to the Pa. Now, coming to this equation, if both the values are same, okay, so log 1 will be equal to 0, okay. So, pH equal to pKa plus 0 will be pK only. So when this will happen, when both the values are same, then pH will be equal to Pa. Next, determination, you can determine the pKa by UV visible spectroscopy method and potentiometric titration method. Next, here they have given a pH of a certain organs, you can see here. So the GIT pH will be around 1 to 8, the whole gastrointestinal tract. Coming to the stomach, 1 to 3 or 1 to 2. Next, intestine, 5 to 8 or 6 to 8. Okay, it depends upon the authors, whatever they will be doing. Next parameter is the pH solubility profile. So what is a pH? Negative logarithm of H plus ion is known as the pH. So most of the drugs, their solubility will depend upon the pH of your solution. So here you can see they have given a drugs, types of drug, more acidic, weak acidic, more moderate, and what is a pK value and what is a pH and how it affects the absorption. Okay. So here assume this is a first one, very weak acid. So what is a pK value of a weak acid? Greater than 8.0. And what is a pH? It remains unionized at all the pH. Okay. So as it remains unionized from the top to the bottom, so what is happening to the absorption? Absorption will also be very good from the top to bottom throughout the whole GIT. Now coming to the second one, moderately weak acid. It is having a value of 2.5 to 7.5 pK value. Now coming to the pH, what will happen? Unionized at a gastric pH means in the stomach it will remain unionized form. Next, at the intestine what will happen? It will convert to the ion. So out of these two regions, your drug will have a maximum absorption in a stomach region. So unionized forms will have more solubility and absorption when compared to the ionized forms. Next, strong acid, less than 2.5. So as a strong acid, whatever you are adding into the aqueous fluids, it will immediately split into the ion. So they get ionized at all pH. So as it is an ion form, it cannot pass through the membrane. So it will have a poor absorption completely. Next, very weak base, pK value is less than 5. What is happening? Unionized at all pH. So what will happen to the absorption? It will have a good absorption throughout the GIT. Moderately weak base, pK value is 5 to 11. Next, coming to the ionization will happen in a stomach, unionization in a intestine. So it will have a good absorption from the intestine. Next, strong base greater than 11, ionized at all pH, so therefore poor absorption. So if you see, the acids are divided into 3 types, bases are divided into 3 types. So here you see the pK value will vary for the strong and the weak and moderately, and the site of absorption and the pH will also differ. If it is unionized at this one, it will be ionized at this one. Okay. So carefully you have to study it. And this table is also very important. They were asked particularly in case of for example, moderately acid. This is a pK value. So what will happen, or from which region maximum absorption will occur? So here the maximum absorption will occur from the stomach because it remains in a unionized form in a stomach. Next is the partition coefficient. So what is the meaning of partition coefficient? Ratio of a drug in a 2 immiscible liquids is known as a partition coefficient. For example, you took some drug, salicylic acid, you add into octanol, add into water. One is organic phase, one is a liquid phase. So how much drug will be dissolved? Again you will estimate by means of UV and HPLC. So that is about the partition coefficient. Equation is concentration of drug in organic phase by concentration of a drug in aqueous phase. So ultimately the partition coefficient will determine whether your drug is hydrophilic or a hydrophobic, more hydrophilic or less hydrophobic, it will determine that. Apart from that, it will also estimate the distribution of a drug in your body. And what are the methods to determine this partition coefficient? Shake flask method. You will be doing in your B Pharmacy practical. You have a separating funnel, you add both immiscible liquids and you add a drug, you shake it, you will keep it after some time without disturbing. Both will get separated. You will collect individually from the separating funnel and you will estimate. That is a shake flask method. Apart from that, you can also use the HPLC, that is a high performance liquid chromatography technique. Next, coming to the chemical properties of a drug substances. So, coming to the chemical properties, hydrolysis, oxidation and reduction, resimerization and polymerization. Now, coming to the first property is the hydrolysis. So, hydrolysis is nothing but breakage of a bond in a compound is known as a hydrolysis. So, hydrolysis means it is a reaction of a drug molecule with a water resulting in a cleavage of a chemical bond. So, and ultimately due to the cleavage, what is happening? The product is completely decomposing or degrading. So, example of a drugs which will undergo hydrolysis or decomposition are esters, amides and lactams. Next, hydrolysis are again they are of two types, acid based and base based. So, coming to the first one is a acid based hydrolysis. So, here you can see this will be also opposite. So, in case of acid based hydrolysis, the water will act as a base. It is a acid, but here it will act as a base. So, example they have given a acetic acid. To the acetic acid when water is added, so it will split into the plus and minus sign, hydronium ion. Okay. So, this is an example of an acid base hydrolysis. Second one, base base hydrolysis. So, as it is a base, here the water will act as an acid. So, example is an pyridine example. Next, how you can prevent the hydrolysis? Because you can see in some products like amides, lactams, esters, this will occur. So, you cannot throw that drug. So, you can prevent it by taking some measures. So, what are the preventive measures? You can add buffers, additives, surfactants. Okay. Next, modify the chemical structure. You add some functional group or something, you add some salt to that. Next, replacing the aqueous solvent with a non-aqueous solvent. Next, reduce the exposure to water. As it is exposed to the water, completely the bond is breaking between the atoms. Okay. So, reduce the exposure to the water. Next, convert the drugs into the dry powder. Dry powder means the moisture content will be the less. So, there will be no hydrolysis reaction. So, example of a drugs which will undergo here, they are also given aspirin, penicillin and diamorphine. Next one is the oxidation and reduction. So, what is oxidation? Loss of electrons, gain of electrons. In most of the cases, oxidation and reduction will occur combinedly and such type of reactions are known as redox reactions. So, coming to this redox reaction, basically it will occur in many compounds. Next, oxidation, it is of two types, auto-oxidation and free radical chain process. So, coming to the auto means self, okay. By itself the compound will undergo to the oxidized product. So, it is known as auto-oxidation. Next, coming to the free radical chain process, this will occur in 3 steps, okay. Initiation means starting, propagation means prolonging, termination means stopping. So, these are the 3 steps in the formation of a product. First one, during initiation, the compound is converted into the free radical. Second step, in propagation step, the free radical will combine with the oxygen to form peroxy free radical. Next, third step, termination. Peroxy radical is further again combined with a hydrogen and it forms a hydroperoxide. By this step, completely termination will occur. So, ultimately it forms the inactive product or undesirable product. So, how you can prevent these reactions? Okay, use of antioxidants and chelating agents. Next, reduce the contact or completely avoid the contact of the drug with a heavy metals. Next, addition of reducing agents, addition of pH buffers or pH adjusting by adding a buffering agents. Next, replace the oxygen with a nitrogen in the containers. Apart from that, you can also store your formulation in a dark and cool containers. Next, racemization. So, here what is happening? Whatever the optically active compound is there, it is converting into the optically inactive compound. So, some compounds under the view of a light, okay, they will convert into a one form and another form, okay, polarized light, under polarized light, levo form and dextro form. So, ultimately some products after converting, they will be of a mirror images. Next, the rate of this decomposition process will depend on the presence of catalytic hydrogen, hydroxyl ion, heat, light, temperature and solvent. So, all this will affect the process of racemization. Next, interconversion can alter the pharmacokinetic properties such as ADME, means if it is in a one form, if it has been converted into another form. So, ultimately absorption properties, ultimately pharmacokinetic properties will be affected. If pharmacokinetic properties are affected, pharmacological, and it will also lead to the toxic product. Next, this conversion can make the drug either inert or danger product. So, example here is levo form of epinephrine is 15 to 20 times active when compared to the dextro form. Okay. For example, you have prepared a dextro form, better you take a levo form because levo form is more active when compared to the dextro form. Coming to the next one is the polymerization. So, coming to the polymerization is nothing but formation of a polymers through a reaction is known as a polymerization. Again, polymerization is of two types, additive and condensation. So, in additive type, if any two reactants are combining and it has been formed as some product, okay, and it has not given any byproducts, then it is known as an additive reaction. Coming to the condensation, if two reactants are combined, it will form a product. Apart from that product, it will form a byproduct such as water or a ammonia. So, if any byproduct is there, formation is there, then it is known as conduction. If there is no byproduct formation, then it is known as an additive reaction. So, examples are shellac. So, shellac on aging undergoes polymerization. Next, glucose solution will also undergo polymerization. Formaldehyde solution again on storage will undergo polymerization, it will convert into a white solution. So, these are the different properties of the preformulation studies. So, we have studied the physical properties as well as the chemical properties. Now, next is a application. So, coming to the application of the preformulation is drug delivery technologies, okay, like preparation of a solid dispersion, sets or nanoparticles or some technique if you have opted, then it will be helpful. Next, pharmacokinetic optimization in a drug research means ADME, if you are altering anything, if it is increased, then it all will be also helpful. Last one, in the process of drug discovery and the early development. So, all these are the applications of the preformulations. So, thank you everyone.